Hello, everybody. My name is Damien Taik. We are Clay Top Engineering from Yangon, Myanmar. And of course, our country is known as Burma in some parts of the world. And we are offering open lectures. And we want to contribute in promoting access to good quality education for the students all over the world. And we will have a lot of lecture series. And the first lecture series that we will have is mechanics. And the reason we try to select mechanics is because it's important fundamentals in engineering and undergraduate degree programs. And if you look at the upper secondary level, for example, in A level, it's one of the subjects that you have to sit if you are following the track of engineering, technology, and computer science in the future. And there's the reason we try to choose mechanics as the first open lecture series. And the textbook that we are going to use is Mechanics 2, student book by Joe Skrakowsi and Harry Smith. And if you are familiar with International A-Level exam, and that is the book published by Pearson, Edexcel, International A-Level, and it's Mechanics 2, a student book. And as I have said earlier, series editors are Joe Skrakowsi and Harry Smith, and of course there are many authors in this book. So we were trying to cover all the topics in this textbook. The first topics that we will do is projectile motion, and of course is constant speed and constant acceleration motion. And chapter 2 we will have variable acceleration, and of course the acceleration itself vary with respect to the time, and that's the reason we have to use a lot of differential and integral calculus in chapter 2. Chapter 3 is centers of mass, and in that we will determine the centers of mass of the plane lamina and also the framework, and sometimes plane lamina and framework attached with some masses in the system. We will also touch a little bit on the stability. And chapter 4 we will have working energy, and chapter 5 is impulses of collisions, and finally we will have statics of rigid bodies. So those are the topics that we will cover in the open lecture. And of course we were trying to complete this textbook including the problem sets. So if you follow very closely with our open lecture series, at the end of this course you are able to sit the A-level exam. And of course we may not do all the problems because some of the problems are just in the same kind of category, and in this case we will categorize the problems into some categories, and of course we will definitely do sufficient numbers of problems that fall under the same topics. So those are the textbook and the way that we will offer the lectures. And for the kind of comfort and ease of the students, we were trying to limit our videos like 15 to 20 minutes for one video, so that you will enjoy learning with the short videos. I know if the video is too long, we really kind of encourage the students to learn. So that's the reason we were trying to limit our video as short as possible. So mostly between 15 and 20 minutes. And now this video, before we even start the main content in the textbook, let's start with some of the fundamentals or prerequisites that you might have learned in the O-level or even in equivalent higher education, basic education in your country system. So today we will just start with the constant speed motion, and also accelerating and decelerating motion. And let's just start with a constant speed motion. And of course, when you discuss the motion, we have position, velocity, displacement, and acceleration. And if you look at the velocity, which is just the rate of change of displacement with respect to time, or rate of change of position with respect to time. And of course, your rate of change in displacement is just S1 divided by S2. And the change in time is T2 minus T1. And for the acceleration, it's the rate of change of velocity. So this will be just v2 minus v1 divided by t2 minus t1. So in these two equations, if you look at the displacement or the velocity, they are vectors. So this means if you decide the direction of the velocity, the direction of the two displacements are really important. Also, if you decide the direction of the acceleration, the direction of the two velocities are really important. But if you look at the denominator, which is just the t2 minus t1, of course the time is scalar. So your denominator is just a scalar and it does not contribute in the uh, direction of acceleration or velocity. So sometimes if we are interested only in the direction of velocity and acceleration, we will just look at the position or the velocity vector only. And here, for the sake of simplicity, we will just take t2 minus t1 as 1 second. So this means your time step at 1 second, and this of course simplify your velocity and acceleration expression. Your acceleration will be just v2 minus v1, and of course again, if your time step is not 1, it doesn't matter because it does not affect the direction of the acceleration. And now if you look at the constant speed or uniform velocity motion, since the speed of velocity is constant, you have v2 is equal to v1, and of course this from this your acceleration will be just 0. And so for constant speed motion, your acceleration is 0. So you understand mathematically. But sometimes we like to see also with the graphical form. So you have a kind of Cartesian coordinate with the time t in the x-axis and velocity v in the y-axis. Now if you have constant speed or uniform velocity motion, your velocity will be constant all the time. And of course from there you can see easily, again from your mathematics, you know the acceleration, the rate of change of time, which means it's just the slope or gradient of the velocity time graph. So if you look at the velocity time graph, since the velocity is 0, so the slope or gradient will be just equal to 0. So this means your acceleration will be just 0. So now you understand the constant speed motion both mathematically and graphically. We also can look at this, the so-called vectorically, and that's really important because at the end of the day, determining the directional acceleration for the more complex system is not really straightforward, and you should start to build up those kind of foundation or know a way to determine the directional acceleration using the vector diagram. So for this, we will have a kind of the so-called particle motion diagram, and sometimes we will just call the particle model. So basically what we were trying to trace the position of the particles at different times. So let's look at an example here. We have a kind of one-dimensional coordinate system. Positive x is taken if the particle is moving to the right. Now of course this means if the particle move to the left, we will take the position as negative value. So you have the coordinate origin here. We were trying to trace out the particle position at different times. At time t is equal to 0, your particle will be just here. At time t is equal to 1 second, your particle, let's say, is just there. At time t is equal to 2 seconds, it will be there. And if you take the time step 1, in our case, the time step is just 1, your velocity will be just inferred. The displacement vector between two time steps. So you have a kind of the velocity vector here. So this is just v1. Again, please notice that here the time step is just 1 second. So there's a reason your velocity vector is just the rate of change of position between two different times. So it will be just equal to the interval between the two time steps. And for the second time step, you have the velocity v2 here. So again, having the particle motion diagram is really helpful because just looking at the diagram, you can easily see, or you can easily make sense of the rate of change of velocity with respect to time. So if you look at this diagram, the rate of change of velocity is constant. Rate of change of velocity is zero because uh, the velocity is just constant. So if you look at both the length of the velocity vector v1 and v2, and the direction does not change. So this means there's no change in the velocity or speed. So that is the reason we will have the acceleration zero. And of course, if you look at that, if you want to find the acceleration, it's just the vector difference between v2 and v1. Basically, you are trying to subtract vector v1 from v2. So let's try to do the vector diagram. So you have v2, and you want to subtract v1 from that. So you draw negative v1 because you want to subtract. So you try to reverse the direction of the velocity vector v1. So from this diagram, you can easily see, since the magnitudes of the two vectors are the same and the direction is opposite, the resultant vector, which is the acceleration vector, will be just zero. All right, so I hope from our discussion now you understand the constant speed motion in mathematical sense, also in graphical sense, and also in the vector sense. And as I have said earlier, understanding the vector diagram is really more important when you trying to determine the direction of acceleration for the rather more complicated system in the future. So for the next step, we will have the vector diagram straight away. All right, now let's try to look at the accelerating motion. So if your particle is accelerating, and of course this means, acceleration, the rate of change of velocity. So this means the velocity changes is the velocity is increasing, right? So as I said earlier, we will just straight away do the vector diagram, and we will try to look at kind of two different motion. Your object can be moving to the left or to the right, but it can still accelerate. So we will try to first look at the object going in the positive x direction. So this means object is going to the right, but it's accelerating. So as we have said earlier, at time t is equal to 0, your object will be here. At time t is equal to 1 second, your object will be there. At time t is equal to 2 seconds, your object will be there. And as you can see here, since the object is speeding up or accelerating, the second vector is longer than the first vector, and this means your object is speeding up, of course. So this is vector v1, and this is the velocity vector v2. And again, as you see, the length of v2 is longer because the object velocity is increasing, right? So now acceleration is the vector difference between v2 and v1. So you were trying to subtract v1 from v2. I will first draw v2 and then negative v1 because we want to subtract v1 from v2. And as you can see from the graph, now the acceleration is not zero. I mean, the resultant of the vector difference is not zero. So if you want to find the resultant, you just connect the start of the first vector to the end of the last or second vector. Here, if you connect this, we will have the acceleration going to the right as well. So what we have from this vector diagram, we can easily see your object is accelerating, it's moving to the right, so the velocity is positive. And based on our resultant vector, we can also conclude that the acceleration is also positive. So from that, we can conclude for the object which is accelerating, and if it is moving to the right, both the velocity and acceleration is positive. And now let's try to look at that if the object is going to the right, going to the left in the negative x direction, as we have done it before. At time t is equal to 0, your object is here. At time t is equal to 1 second, your object is here. And now it's moving to the left. And now at time t is equal to 2 seconds, your object is another position. Of course, in the second time step, the vector is longer because your object is speeding up. Now the velocity v1 is in this direction, and the velocity v2, the length is longer than v1. And then you want to find the resultant vector of the two vectors difference, and you try to first draw vector v2, and you are trying to draw the negative v1, So you will have negative v1 here. And now you can easily see your resultant vector is from the start of the first vector and the end of the second vector. So this is your acceleration vector. And now from this diagram, again, you can easily see that the acceleration is negative if your object is speeding up and if your object is moving to the left. And now if your object is moving to the right or negative, if it is accelerating, your acceleration will be also in the negative direction or moving to the left. So based on that two types of motion that we have just seen, we can conclude that if your object is accelerating, so for an accelerating object, so what we have is the direction of acceleration. So I will just here as the abbreviation A is always the same to that of the velocity. So this means velocity and acceleration are always in the same direction if your object is accelerating or speeding up. The same with that of the velocity. Right. Okay, so what we have here, again, I will just repeat myself. If your object is speeding up or accelerating, the direction of acceleration is always the same with the direction of the velocity. All right, now let's try to look at the decelerating motion. What happens if your object is decelerating? And of course, if your object is decelerating, the velocity in the second time step is shorter or smaller than the velocity in the first time step. So let's try to look at that. And now again, we will start with your object moving to the right. So you have origin O here. At time t is equal to 0, your object here. At time t is equal to 1 second, your object there. At time t is equal to 2 seconds, your object here. And if you look at here, the velocity vector v1 is longer than the velocity vector v2 because your object is slowing down or decelerating. And now in order to determine the direction of the acceleration, we will do the vector difference between vector v2 and v1. So we will first draw v2 and then we will draw negative v1. So if you look at that, negative v1 is longer than v2, and your resultant vector will be from the start of the first vector to the end of the second vector. So you can clearly see the acceleration is moving to the left. And notice that the two velocities are moving to the right. I mean, they are positive, but the acceleration is negative. So you will have positive velocity, but if your object is decelerating, your acceleration will be negative. So what does it mean? It means that if you have decelerating object, the direction of acceleration is opposite to the direction of velocity. And now let's try to look at the object which is moving to the left, but again it's decelerating. We will start with object position at time t is equal to 0 at the origin, and time t is equal to 1 second, it will be somewhere here, and time t is equal to 2 seconds, it will be around there. And now if you look at the two velocity, there is velocity vector v1 and that is the velocity vector v2, and you want to find the vector difference. So what we do is we will draw vector v2 and then negative v1, and your resultant vector between the two vector difference, which is the acceleration vector. And now you can easily see if your object is decelerating and if the velocity is negative, your acceleration is positive. Right. So based on again these two motions, we can conclude for a decelerating object, the direction of acceleration is always, in fact, opposite to that of velocity. Alright, so now we have learned three different kinds of motion. The first one is constant speed. For the constant speed, the acceleration is 0. For accelerating motion, the direction acceleration is always the same as that of the velocity. So this means if the velocity is positive, acceleration is positive. If the velocity is negative, acceleration is negative as well. But if your object is decelerating, the direction of acceleration is always opposite to that of the velocity. So this means if velocity is moving to the right, acceleration is negative. If your object is moving to the left, acceleration direction is to the right. So just remember those important points from this video. And now, before we say goodbye, I just would like to share the quiz with you. So we have a very small quiz here. So the question is, for an object which is slowing down or decelerating, which one of the following is true? And of course, just if you understand the three types of motion that we have just discussed, for decelerating object, you can clearly see that the direction of the acceleration is always opposite to that of the velocity. So you just have to find the answer where the direction of the acceleration is opposite to that of velocity. So if you look at A, the velocity is negative and the acceleration is positive. And of course, since the two directions are opposite, this means the object is decelerating and your correct answer is A. And now you are very confident based on the knowledge that we have just discussed. And of course, in the examination, having that confidence level is really good for you because you can save time and because you are very sure A is the correct answer. But here, let's try to look at other options as well. If you look at B, the velocity is negative, acceleration is negative. So this means they are in the same direction and both are in the negative direction. So this means your object is speeding up or accelerating. So if you look at C, your object is positive, acceleration is positive. Again, they are in the same direction, they are moving, your object is moving to the right. And since the acceleration is in the same direction with the velocity, so this means your object is accelerating. If you look at B, velocity is positive, acceleration is 0. And of course, this means your object is moving to the right and is moving at constant speed or uniform velocity. Alright, so I think that is all about today's. And again, before we say goodbye, there are 3 points that you have to take from this video. For the constant speed, acceleration is 0. For the accelerating motion, direction of the acceleration is the same with that of the velocity. And of course, this means acceleration direction is always in the direction of the motion. And for the decelerating motion, direction of acceleration is always opposite to that of the velocity. So this means the direction of acceleration is always against the direction of the motion. And with that, I think we will just say goodbye. And in the next video, we will try to look at free falling motion. So please subscribe to our channel and of course think of some topics that we discussed and see you in the next video.